Yeah, I'll start streaming and see if anybody was trying to join. Nice.
So I don't really have any questions, but I'm just going to go back and do homework too again, because I want to do it again and do it better based on like, the comments you gave me and everything.
Okay.
So yeah.
Yeah, did you want to look at the comments together? Or,
Yeah.
I mean, we got time, so.
I mean, she was helpful. I like it was emailing her back and forth, and she like pretty much explained it all to me. It was great.
Awesome. Yeah, Carolyn has been doing a great job going back and revising things. So if you're joining and you do want to pop into the chat and ask any questions, everything's open. At this point, we have gone through modules 1, 2, 3, and 4. If you haven't submitted module 4 work, that's okay, as long as you have a plan for getting stuff in. And then module 5 is kind of like next week when we get back, we can look at that. Different people have different schedules. Some people come in last week of school is all projects and midterm 3. Other people have all review all week, and then finals week is busy. So depending on where you are, plan is to submit module 5 stuff Friday, end of the semester. But if you're busy that week, let us know that it'll be the next week. But yeah, pop into the chat if you need anything. We're gonna work on some stuff here.
I have another question about like the project 5, homework 5.
Oh yeah.
That like how's that operating? Like is that required? Is that optional?
That one's optional. Yeah.
Is it like a replacement system or just an add-on system?
It would just add on.
Okay.
Yeah.
If you do it and then it goes to the web, is it supposed to be add-on?
Never heard.
Okay.
No. Like even if you only did one problem and it was wrong, you get 5 points.
Okay.
So,
Me and my friend were working on it yesterday, and we were just like, I don't know, like exactly, I didn't know exactly what the system was for it.
Yeah. Yeah, no, that would be pretty mean. Gotcha. Extra credit, but
Okay.
yeah. And this was, so what was module 2? Like what was the, I go back to that one.
It was, oh,
Oh, okay.
I wrote 50 the first time I did it, I redid it, I was 70, and I was like, and when I worked, I was getting like 80 times.
Oh, okay, so this one.
Like that.
Yeah.
Yeah, the other one helped. So I went back, I fixed the transistor, the count of the first one. And then for the second time was about problems too. And so I watched a bunch of videos for that one. And one of my friends was doing the first section of the class, so I worked with on everything, but I still was like, this one. Is this what graph is supposed to look like?
So this one is looking at like the transistor data instead of this plot. This is like the ADV versus IDV.
Yeah.
Problem plot. So you can't like one way to do this is sort of like copy this and put it backwards.
Okay. I was trying to do that. So it like worked in class, and then at home it wasn't working. But
Oh really?
yeah, but I think I just screwed up like some mistakes or something.
is,
And then work backwards by defining it.
yeah,
Okay.
so you can like go find where was value. That's right.
Okay, so once you're back, you go backwards, you find out all the things in there, and then it'll output a different graph.
Yep.
Which I think is what the common thing is, so student presentation, because I got through A, and I got to B. And then I went how to graph, so I don't know how to compare the two graphs.
Oh, okay. Yeah, so the other graph is that, the one from the beginning.
Oh, the other graph's this one.
This one. Yeah.
Oh, okay, okay.
Yeah. There we go. Copy image objects.
The worst change is when you're supposed to do it,
So Markdown just displays like text.
okay.
So that's like all the questions are written down.
Okay.
I like it because you can mix and match.
So
Your
oh,
show.
okay. And then you're comparing that graph to the graph I was measuring.
Yeah.
Okay.
Yep. That's like, because it's a website that's displaying Python code, you can grab things from other websites and display them.
And then next time I was off, so we go back and fix that, so I ended up getting like the last
That's
one.
kind of cool because here you have like comparison.
Yeah.
Is that what you wanted to do?
So when I was working through it with my friend, he sort of explained it as like if you have all this and you like sort of like explain the difference between all these years.
Yeah.
And like approach it from that way. And you also get like the red lines are your average sheet answer, like if you have a 17 points and like you think it, you know,
Yeah.
and also like see how they like expand throughout that line.
That's good.
So that's that. And then I was trying to get like the general line book timeline.
Yeah. Okay.
But yeah, I went back and copied the code from the end of the class videos.
Okay.
And it outputted to the star format. But then I didn't really know like how to interpret it out. But I was like, okay, I can copy this and put it on the code. I don't really quite know how to also answer the question based on that. But okay.
Yeah.
Because it was asking for like sliding off, this one, turning off, this status bar. And so like I know that's what the code is asking for, but like it was just saying that like this is the root and this is like the output.
Yeah. So like in the 80s we had, or like 1980, there were 10,000 transistors on every microchip.
Okay. So it's gone up.
Yeah.
Okay.
2020, now we're at
Almost
10 billion transistors.
Okay. Okay. Yeah, because I was like, I can like copy it and get the same graph, so I know it's coding it, and I can
Yeah. Yeah, and here the tricky part is trying to color it based on design. I think that's this button.
Yeah.
Okay.
Yeah. Color the data according to designer, which I didn't do at all, but I was like, I want to understand the graph first.
Yeah.
Go back through.
Well, here you did. It's just every design is blue.
Right.
So, perfect. That's a They're all okay.
Okay,
It's hard to tell the difference, but we did fine.
Oh, so they're all supposed to be good.
Like ideally, they're all like you can distinguish like what Intel did versus IBM versus like Nintendo has a couple of chips that it made. So that's what we're trying. I thought I saw that around somewhere. You scroll up or down.
Yeah.
Right.
Yeah. Yeah. Okay, that makes sense.
So that's what you did there.
Well, so this is the one I worked on with my friend, but I wanted to keep both because I wasn't quite sure they were going to play.
Okay.
Like, he was trying to get this, but then he code wasn't working, so he was using it, and so I was able to fix the code and get the graph, but I was like, I don't quite know that like that's any different than what we did in class, other than like the color. But I sort of get it like now with all these different colors and all the different ones.
Yeah.
Okay. I feel like when I do that, I'm like fix the code for output something and I don't necessarily know what I'm outputting.
Yeah.
If that makes sense. And then oh, criteria I also got it, so I have the zero. And you guys put in the output and then the average of the two throughout the years. That's what I was trying to go for that. I'm not quite sure the differences, but I was trying to get like sort of the general like difference between the two.
So I think so right here, because I'm looking at so first you create US energy, and you create EU energy, and then you make a fit. So you're doing the first order polyfill.
Oh.
Apply US data, applying your US fit. So red line is a red fit.
Okay.
And then EU has no fit.
I wanted to add a fit, so
okay.
Okay. So I'm gonna like put in
you can, so if you want to add pound signs, then rerun that.
Yeah. I'll rerun it all over. Okay, so I'll add a fit so you can use it. And then I think I understood the last one.
Oh yeah. That's usually the hard stuff. Oh, it looks like it's outputs. Like this from the last part.
Okay.
But here it looks like you did that.
Yeah, so
that first part.
Third time we're doing this one, and I think I learned it in the first one,
Okay.
and I did it in this, and I was going to do.
Okay.
So I just wanted to like go back and try it again, and I get those last pieces.
Yeah.
So after this, I'm presenting her email, and she helped me work through it and to get this plot for the work one, and then I just want to like be able to like, yeah, then do it, and then just want to be able to like go one paragraph and come out of it. And then
okay. Yeah, and this one is like
yeah.
It's just the starter.
It's just the starter, and I haven't even put it in the code yet. But that's really pretty easy. Okay, another small one. I just wanted to go through the comments and make sure I was like throwing out of it.
I mean, it looks like
I'm pretty sure I can.
yeah. And you had, I guess you, and I know you have like the process of kind of like, yeah, one big work, but keeping it where it's at. But yeah. I think as you organize like inputs and outputs, most of the work is done. That last part, like that last question is like,
yeah,
hasn't really gotten started.
And yeah, I didn't go last question. It's just for like sales and stuff. Oh, there's just one last question on this one. So when I was running it, I'm trying to really said, it's really that it should have an active appendix, right? It shouldn't just be real. Like when I do the exam, there should be
Which question is this?
question 2 about the same spots.
This one is looking at like another best fit for him.
Yeah, so it should be just that.
Yeah.
Okay, so it should be that level 1. I think that was one. Like, I don't know why it's so weird. I don't know
This one, I mean, it looks like something that you're starting from the last, like this.
yeah, I'm not even
The 98.1, that is the load on it.
I think I'm not even like from the line above. And when I go on there, I'll put it in the question and then put that to go back and also.
Yeah, it also has like the EC on it, like E critical.
Which is all the stuff that I'm trying to do. Yeah. Okay. Awesome. That was all my questions about that. I want to go through and make sure I like understand a little bit of the system.
Okay.
So I'll probably just work on that delivery and then we put it.
Okay.
And then do project assessments and project tasks.
Okay. Yeah. You want to work through module 5?
Yeah. I want to do it just in case.
Yeah.
So it doesn't hurt at this point.
It definitely will not hurt. Yeah. I think it's cool.
Yeah.
But
I was not even outside of like that, but yeah.
yeah.
Well, thank you for helping.
Yeah. You're welcome.
Yeah. Well, because I did it the first time and I was confused, and I redid it and I was like, what? I'm just gonna go and ask in person just to make sure I understand like what the
Yeah.
I'm asking for.
Yeah. Thanks for coming in.
But it's also so quiet.
It's kind of nice.
All my friends are like home. I drove 3 different people to the airport yesterday. Like everyone's going home.
I have a class at noon at like 12:30 today.
Yeah.
And on Wednesday I asked like, is anyone going to be here? Yeah. No.
Yeah, no, I'm going back to the airport in like a couple hours to drop a few more people off. Like,
Yeah.
we're just out of here.
Yeah, it's been a long, I think a lot of people have been waiting too long for this break.
Yes.
Can't
It's so
come
late
quick enough.
this year.
It's so late.
much longer.
Yeah. Okay.
Thanksgiving.
Happy Thanksgiving. Are you traveling, Anna?
I'm technically out of state, but I just go to Massachusetts, so it's not that far.
Nice. Yeah. All right. Enjoy. How are we doing? Do we have any people joining us? Are there any questions about, let's see. Looks like we still have people online. Do you have any questions about either what's it called? Module 5 or any previous modules? Like, what are people working on? If you're joining and interested in the work, what's going on? I'm just trying to get this one set up. So I'm here. Figure I got like 20 minutes. No, we got a full half an hour. I could try just doing some fun stuff. It's always fun to mess around with Python and Jupyter. So let's take a look. We could jump right into maybe homework 5. So there are readings to support. Oh, and homework 5. First thing that we have to deal with is the fact that I forgot to put a .md at the end of the link. We can always fix this. So if I double click, I can change this HW05. If I add that .md here, then it's gonna know. Then it knows where that homework 5 is. So when I hit Shift Enter, now when I click it, it'll work and it actually gets me to the right spot. But if I don't have that, if you don't feel like looking behind the curtain at the markdown code, and you just click homework 5, come up to this the URL and add that .md up here. Right, and so we're trying to add that .md right at the end at this spot. And once I do that, it goes from a 404 not found to, yes, I know exactly where it is. Okay, so now I have this simply supported beam with a distributed load, which means that the shape of the beam is going to be this x to the 4th power polynomial. And first thing that I want to do is be able to evaluate, like find points on this beam. So let me make a function. I'll say w is going to be lambda of x, where here I want to define my L equals 1, E equals 200 E9, I equals 0.01 to the 4th over 12, and then Q is going to be 100 Newton per meter. I don't know why I didn't put units on the rest of the stuff. Meter to the 4th, Newton per meter squared, and then meter. Cool. And this is going to be negative Q times X times L cubed minus 2 times X squared times L plus X cubed, all over 24 over E over I. I want points at 0, 0.1, 0.2, all the way up to 1. So if I use linspace, I want 10 equally spaced things, which mean I need 11 spots. So I'll use linspace 11, 0 to 1. And let's just see what my function looks like so far. X and W of X. That looks like a simply supported beam. So there's no moment applied on either end. So the slope, it has like a big slope because there's no, if it was fixed points on either end, then we would have 0 slope. Here we've got that big slope, no shear stress at those ends, and then kind of comes down like this in this big quadratic, or almost a parabola, but quadratic kind of function. And these are x's like that. Now let's do squares. So this is like it's a continuous function, but the idea is that here I'm measuring certain points along this beam, and I want to take derivatives to figure out what is the first derivative, second derivative, third derivative at these points based on their neighboring measurements. So you could think of this as like, I have a simply supported beam and I'm actually using a caliper to measure, like, okay, how far did it deflect at half a meter? How far did it deflect at 0.9 meters? I know we have a continuously, like we can evaluate this function wherever we want, but we're going to just say we want the forward, backward. So we'll call it like WM for like W measured is W of X. And I've got 11 different spots where I measured something. So dW for forward difference, that's going to be, I'm taking, if I want the derivative at x equals 0, I'm going to use x equals 0 and x equals 1, and I take the second minus the first. So it's going to be Wm bracket 1 to, 1 to the end minus Wm of 0 to negative 1 all over the dx. So we'll call it like x1 to the end minus x0 to negative 1, like that. dw forward. And I'm just going to try to plot it. Let's see what happens. I get this issue that they don't have the same shape, where I'm using these 11 points to calculate the slope at the nearest, based on the nearest neighbor, the next nearest neighbor. But at this point, at point 1, there is no forward difference spot to go to. So there is no 1.1, x equals 1.1 to say 1.1 minus 1 and whatever that derivative is up there. So I can't do this. I need to truncate, I need to get rid of one of those x values. And for forward difference, I'm going to get rid of the very last value. So I'm going to go start at 0 and go all the way to the second to last value. And now it does not look right, right? I did something wrong. What did I do wrong? Wm, because that can't be right. Oh, whoops. Yeah, because I'm plotting w. Do I want to take some derivatives here? So that might be right. Do I want to take derivatives? Might as well, right? Because it'll help our troubleshooting. Make sure give us something concrete to compare against. So let's go here. I'll say that 24 EI W equals negative Q L cubed X plus 2Q L X squared plus, no, minus, this one should be X, that one's going to be an X cubed, and now a minus QX to the 4. Okay, so now if I want W prime, it's going to be negative QL cubed, X is gone, plus 6 QL X squared minus 4 QX cubed. W double prime is now going to be, that one's gone, a 0 plus 6QL, 2 times 6, so a 12QL times X minus a 12QX squared. All right, now we can actually compare some stuff, right? And might as well. You're not really, so you're not asked to, oh, that's what I want. You're not asked to calculate these out by hand, but if you want, you can. So I have a Q, and I could factor out that Q for all of them, right? But I'm gonna leave that one. So Q, we'll leave it negative. QL cubed minus 6 times QL, and then this one becomes that Q times 4 times that. And then we get rid of this one. That one's still negative 12 QL x. Oh, and this should be x squared, right? Yep, like that. And then that one's negative 12x. This one becomes 12x squared. Okay, now let's try this. So instead of plotting w of x, let's look at dw of x. And I messed something up. Always fun to watch somebody troubleshoot their math, right? So what did I do wrong here? That x becomes just a 1. Six QL x squared. 6L x squared, and then a 4Q x cubed. Negative, negative, negative. I think I'm doing that derivative correct. So dw of x. And this numerical derivative looks better than that derivative, because that one does not look right. Oh, duh. This should be a ddw. I just overwrote that dw with another dw. There we go. Okay. So now I've got those evaluated points, and let's put these as circles. Marker size equals 10. So my numerical derivatives, they look pretty close to what the actual derivatives are. Sometimes the error is really small, other times it gets a little bit bigger, like here in the middle, or a little bit off. Now let's look at backward difference. All right, so we'll do some more math. So backward difference is saying like f of x minus h equals f of x plus f prime of x times h times that negative h. So it's a minus h over 1 plus f double prime of x times h squared over 2, and then a whole bunch of all the higher order terms over there. So solving for that f prime of x for backward equals f of x minus f of x minus h all over h, and then plus other higher order terms, or minus, but there's some error because we have because we're approximating that exact derivative as a finite difference. This looks exactly the same as a forward difference method because I'm taking the nearest neighbors and calculating the slope. So in terms of coding, how do I make a backward difference? It is a forward difference because the actual slopes that I'm calculating are the exact same slopes. For the two nearest neighbors, there's no difference. There's only one line that we can put between those 2 points. So whether I go forward or backward, doesn't matter. The difference comes when I try to plot the result. So if I just try this dw backwards, and so we have squares, we have circles, let's do circle, or maybe we could do like forward and backward triangle. That'd be cool, right? I'm gonna get the same issue that, hey, look, I can't plot 11 x values with only 10 dw values. So I need to take off one of these values. And the question here is, where do I have derivatives? So here at x equals 0, there is no backward difference. So I don't have a slope at x equals 0. So I have to start at 1. And when I get to x equals 1, I do have that previous one. So I can go all the way to the end and say, like, from 1 through the end. So I'm just cutting off that. And forward different here, the up triangle is forward, back triangle is backward, and a nice way to split those up. Overall, like, if you split the difference, they're doing pretty well. Like, this looks pretty good. So why not take a central difference, which should be right in the middle of the two? At least that's the thought, my thought. So to do the central difference, we need this. We need forward and backward. Yeah. F of x plus h equals f of x plus f prime x h over 1 plus f double prime x h squared over 2, all the higher order stuff. So I can take forward and backward, add them together. I want to add them. Yep. Sorry about that. So I get that 2f of x, or do I want to add them? No, I don't want to add them. I want to subtract them. Sorry about that. This minus that one. There we go. X plus h minus f of x minus h. So then I get an f of x minus f of x, 0. And now I can say plus 2 f prime of x h over 1, and then all the other stuff that. So now f prime of x equals f of x plus h minus f of x minus h all over 2 times h. And in practice, kind of what this means is that when I have a function that is doing this, if I want the derivative here, I'm going to use a forward and a backward to calculate the slope through that point. And it seems like I'm still using just 2 data points, but the difference is now I'm using both nearest neighbors, the forward and the backward nearest neighbor. So what does that look like? How do we actually code this? dw central is now going to be wm. Well, let's write it out. Sometime, at least that's the way that I find helps. So if I have w0, oh yeah, let me get my plot back. There we go. So this is W0, W1, W2, W3, W4, W5, W6, W7, W8, W9, W10. So if I want, and then each of these, every H is the same H. So I can always divide by the same 2H value because they're all 0.1. So I want to start at I equals 1. So dw of my central is going to be w of 1. Well, so when I equals 1, it's w2 minus w0 all over 2h. At 2, let's stick to the same format, I equals 2. It's going to be w3 minus w1 all over 2h. Because at this point, I'm going to use this to there. And then here, I'm going to use here to there. So all the way, I can get all the way to w9. So I have dot, dot, dot. At I equals 9, I have w10 minus w8 all over 2h. Cool? So in terms of coding this, I want to say w of 2 to 11, because it's going to go start at 2, end at, and make sure 2 minus, sorry, go to 11 but not include 11, minus w of 0, and at the last one I want to say 8, or this is the end, so I could leave it, and this is the end minus 2, and all that over 2h, so 2 times that. Or I could say, like, yeah, I could use the same, like x of 2 through 11 minus x of 0 through 8, something like that. So I'm going to go from 2 to the end. So 2 colon is going to give me 2 to the end. And then Wm of 0, but go to -2. So stop 2 spots before I get to the end. And all over, let's just plug in the same thing. So we'll start at 2, go to the end, minus 0 through -2, like that. So it's just taking those two near, so it's giving me the, I could calculate h and then do it that way, but it's potato, plot x. And here, we'll plot x. We'll try that first. We'll look at the DW central. And for this one, let's use a star. So now it's telling me that the x still has a dimension of 11, so I have 11 x values, but DWC has dimensions 9, so I'm missing 2 values now because the first and the last derivative that I'm calculating, they have to stop before those endpoints. So I have to go from 1 to -1, because that's the first derivative that I calculated was at W1 or X1, and the last derivative I calculated was I equals 9, so X9. So let's try this one now. Boom, look at that. What color are those stars? Let's do like red, no, black. So it stands out a little bit more. Cool. And now things look really good at this point because the numerical derivative is almost directly on top of our actual derivative. That blue line is a continuous blue line. So things look good. And that brings us to half an hour, a little bit of coding, a little bit of writing things out. So hopefully you enjoyed. I didn't see anything pop up on the chat, but we'll be back after Thanksgiving. So I hope you have a wonderful Thanksgiving break. If you are working on projects, homeworks, or revisions or anything like that, make sure you do take some time over the break to actually take a break. It's been a long semester so far. And we have a week when we get back. So that week is just dedicated to revisions and working on, this is the new Module 5 work. Cool. All right. I appreciate it. Have a great break. You earned